Bismillahirrahmanirrahim. In this lecture, we will discuss sandwich panels. The sandwich panels are an example of a sandwich structured composite material. The strength and the lightness of this technology makes it very popular and widespread all over the world. So its versatility means that the panels have many applications and come in many forms. They have different colors are available in this technology. Uh, Different forms are available in this technology. The core and the skin, these two factors are very important while you are talking about the sandwich panels, because these two parameters are being used for their manufacturing. So this core and skin materials can vary widely, and we will discuss their each and every part of sandwich panel. So let's start. Okay, when we talk about the history and the major development in this field of composite material, these composite cladding systems have extensively been used over a considerable time, especially for the manufacturing of trains and the planes. So their development and advanced sandwich panels were for cladding buildings first began in 1930s. These sandwich panels construction techniques have experienced considerable development in last 40 years. Previously, these sandwich panels were considered products suitable only for the functional construction and industrial buildings. However, their good insulation characteristics, their versatility, quality, and appealing visual appearance have resulted in a growing and a widespread use of the sandwich panels across huge variety of buildings. So in modern world, in modern sandwich panels can be made flat, bent, curved, and joined together in almost unlimited range of configuration. Now sandwich panels are available in a variety of favored colors, uh, lovely finishing and thickness, edges detail according to our performance requirement. So these are very much useful where a high performance cladding is required with good structural strength, a high level of insulation and low weight. Okay, sandwich panels are also known as composite panels. These sandwich panels consist of two layers of a rigid material bonded to either side of a light weight core. The three components act together as a composite, that is, the combination of the characteristics of the components result in a better performance than the individual alone. इसमें हम दो शीट्स लेते हैं जो एक कोर के टॉप और बॉटम पे लगा देते हैं विद एडहेसिव मटेरियल। तो इस तरह से कोर दरम्यान में जो लो डेंसिटी की होती है उस कोर के एक शीट ऊपर लगाते हैं और एक शीट नीचे लगाते हैं, तो जिसको हम एक सैंडविच मटेरियल कहते हैं। सो इस तरह से हमारे पास एक सैंडविच पैनल्स बनते हैं। जो एक्चुअली अ सैंडविच पैनल इज एनी structure made of three layers: a low density core, that is in between two skin layer bonded to each side. The sandwich panels are used in different applications where a combination of high structural rigidity and low weight is required. जहाँ पे हमें ज़्यादा structural stiffness and rigidity required होती है और लो वेट रिक्वायर्ड होता है, we will use the sandwich panel in that particular field. So the structural functionality of sandwich panel is similar to the classical beam, where two face two-phase sheets primarily resist the in-plane and later bending loads, while the core material mainly resists the shear load. The idea is to use a light or soft but thicker layer for uh, to serve as a core, and strong but thin layers of the faces shield. This combination results in the increased and overall thickness of the panel, which often improves the structural attributes like bending stiffness and maintain or even reduce the weight. So this lightweight core keeps the two faces in correct position. The core, which is between two layers, so this core keeps the two faces in a correct position, resist shear forces and provide insulation, while the two faces provide durability, weather and impact resistance, and resist the in-plane forces of tension and compression. So the sandwich panels are referred as any structure made of three layers. The two layers, which are thin face sheets, which are made up of carbon, glass, or Kevlar, it is synthetic fiber, and between these two face sheets, a thin, a thick core material, which is made up of foam, honeycomb, and these three components are joined together by using some adhesive material such as liquid resin, adhesive film, or foaming adhesive. So when we join these three components, we will have a product, resultant yield, that is known as sandwich panel. These sandwich panels are used in application where a combination of high structural rigidity and low weight is required. You can see here a typical example of sandwich structured composite material where the two stiff skins are joined together with a lightweight thick core. The core material is normally low strength material, but it is higher thickness provides the sandwich composite with high blending stiffness with overall low density. Open and closed cell structured foam, polystyrene, synthetic foam, or honeycomb can be used as the core material. However, the glass, carbon, carbon fiber, reinforced laminates are widely used as skin material. Sheet metal can also be used as skin material in some cases. Sandwich panels are a very efficient way of providing high blending stiffness at low weight. The stiff, strong facing skins carrying the blending load, while the core resists shear load. The principle of this sandwich panels is the same as traditional I-beam. Long ago, engineers realized that by adding a core to a material, the strength and stiffness could be dramatically increased with very little added weight. Cores, in comparison to the additional structure value, are extremely cost effective With a sandwich structural material, less material is required than with a solid structure. The stiff and strong facing skins carry the bending loads while the core resists the shear loads. So the total deflection depends upon the bending and the shear. So the bending depends on the skin properties and the shear properties depend upon the cores. The bending stiffness can be increased by enhancing the thickness of the beam or the panel with sandwich construction. However, this attribute can be achieved with little increase in the weight. In this table, you can see here in this slide, three parameters are discussed, such as solid material, core thickness, and core thickness. In these three parameters, the core width is increased step by step, and three properties such as stiffness, fractural strength. This is a response when we apply some bending or curving on the sandwich panel, and the third property is the weight. So when you go across, when you increase the width of the core by a multiple of 1t, 2t, and 4t, by increasing the thickness of the core, you can see the stiffness will be enhanced multiple times, many times as compared to the single thickness material. However, the weight is increased to little extent, while the fractional strength has also been achieved to a significant extent up to 9.2. So the result is, when you increase the thickness of the sandwich panel, its stiffness will be increased, its fractional strength will be increased. However, the slight increase in the weight can be noticed. So we can conclude that the sandwich panels with a higher thickness can have a better stiffness and fractional strength. They can resist, they can bear a large amount of strain and load while applying on it. However, when you apply similar amount of load on a material with smaller thickness, then the result will be different. So you can achieve a better result, better stiffness, better strength with higher thickness of the sandwich material. Sandwich panel composite materials can be classified into three major categories. Number one, three-dimensional printed polymer panels. Number two, structural insulated panels. And number three, aluminum composite panels. Due to the availability of 3D printers, which can be used to fabricate complex sandwich panels, and this area has been noticed in the flourishing research covering energy absorption, natural fiber with continuous synthetic fiber, and for the vibration. And the beauty of this technology is for the fabrication of new geometry, complex structure in sandwich panels, which are not possible with other fabrication processes. So these 3D printer polymer panels can be fabricated by using 3D printers, and these panels have a variety of their geometry. So depending upon the aesthetic sense of the customer, different complex geometry sandwich panels can be achieved by using the 3D printer. The second type of sandwich panels is structural insulated panels. These structural insulated panels are a form of sandwich panel which are used in construction industry extensively. Structural insulating panels is a sandwich structure composite consisting of an insulating layer of rigid core sandwiched between two layers of structural board used as building material. The, the material for the board that can be used to fabricate structural insulated panels may be of different types such as metal, plywood, cement, and these material can be discussed in next slide. The structural insulated panels share the same structural properties as an I-beam or I-column. The rigid insulation core of the structural insulated panel act as a web, while the sheathing fulfill the function of the flanks. They can be These structural insulated panels can be used for many different applications such as exterior wall, roof, floor, or foundation systems. The production of structural insulated panels was started in 1940s when different companies and customers developed corrugated paperboard cores with different skin materials of plywood or tempered hardwood, and these composite materials were tested over a different period of time. When the buildings which were made with structural insulated panels were dismantled, and most of the panels retained the original strength. These panels consist of polystyrene core and different building material on their either side. Structural insulated panels consist of an insulating layer of rigid core which is sandwiched between two layers of structural board. These structural boards may be of sheet metal, plywood, cement, magnesium oxide board MgO, or oriented strand board OSB. These are different materials that can be used to fabricate structural insulated panels, while the core that is sandwiched between these two material may be of different types. For example, if it's expanded polystyrene foam, it's EPS, extruded polystyrene foam XPS, polyurethane foam and composite honeycomb can also be used as a rigid core between the structural insulated panel. However, the most commonly used structural insulated panels are made of OSB, oriented stand board panels, which is sandwiched around a foam core which is made up of expanded polystyrene EPS or extruded polystyrene or rigid polyurethane foam. Other materials can also be used in replacement of oriented stand boards such as plywood, pressure treated plywood, or foundation walls, steels, aluminum, cement board. These can all can be replaced with oriented stand board. The structural insulated panels use fiber cement or plywood sheet for the panels and agricultural fiber such as wheat straw for the core. The third important parameter of structural insulated panel is a spline or connector piece between SIP structural insulated panels. When you are going to join or fabricate a structural insulated panels, you need three components. The first one is the structural board, the second is the core, and third one is the connector piece. Dimensional number is most commonly used, but this has been found to create thermal bridging and lowers insulation value. To maintain the higher insulation values through the spline, the uses manufacturers use insulated lumber, composite composite spline or mechanical log, overlapping OSB panels, or other different useful methods that can be much fruitful for the production and the fabrication of structural insulated panels. Structural insulated panels are most often manufactured in traditional factory processing equipment that is used to regulate pressure and heat in a uniform and consistent style or manner. There are two main processing methods which correspond to the material used for the structural insulated panel core. When manufacturing a panel with polystyrene core, both pressure and heat are required to ensure the bonding glue has penetrated and set completely. Although a number of variations exist, however, the foam core is first covered with a adhesive and skin is set in place in general method. The three pieces are set into a large clamping device and pressure and heat are applied. The three pieces must stay in clamping device until the glue has cured completely. When you are using polystyrene as a core to fabricate structural insulated panel, pressure and heat are applied and this pressure and heat are maintained as long as the bonding glue will be penetrated and settled completely. The adhesive material is first coated over the foam core to cover it, and then skin is set in place. Now the three pieces are set into a large clamping device. After setting the three pieces into a large clamping device, both pressure and heat will be applied, and the three pieces must stay in the clamping device until the glue has completely cured. If you want to use polyurethane in place of polystyrene for manufacturing structural insulated panels, the following protocol will be observed. When manufacturing a panel with a polyurethane core, pressure and heat are generated from the expansion of the foam during the foaming process. The skin are set in a large clamping device which function as a mold. The skin must be held apart from each other to allow the liquid polyurethane material to flow into the device. Once in the device, the foam begins to rise. The mold is generally configured to withstand the heat and the pressure generated from the chemical foaming. The structural insulated panel is left in the mold to cure slightly, and when removed will continue to cure for several days. There are some potential benefit of using structural insulated panel in different buildings. A well-built home by using structural insulated panel will have a tighter building envelope, and the walls will have higher insulating properties, which leads to the fewer drafts and decrease in operating cost. So when you are using such type of building which has high level of insulation, then you will be using less power, less energy, and the temperature of the building will be retained to a higher extent. In summer or in winter, the houses are usually maintained at uh, 25 degrees Celsius or 26 degrees Celsius. If the houses are insulated properly, then the heating or the cooling will be retained in the building, and the energy prices and the energy cost will be reduced by using the structural insulated panels. And due to the standardized and all-in-one nature of structural insulated panels, the construction time will be less than that of the traditional frame home. So if you are using the structural insulated panels, you will be having a lesser number of trading people, as these structural insulated panels are all-in-one in nature. These panels can be used as floor, walls, and roof with the use of this panel as the floor being of the particular benefit when used above the uninsulated space below. As a result, the total life cycle cost of the structural insulated panel constructed home will be lower up to 40% when it will be compared with a traditional or conventionally built a house. So when these structural insulated panels were tested to be used in wall, foundation, floor or roof system, it is these structural insulated panels are installed in a steady state, no air infiltration, so energy will be conserved. System incorporating fiberglass insulation are not installed in steady state environment as they have required ventilation to remove the moisture. So these are the major and potential benefits of using structural insulated panels. They will have energy conserved due to the tighter building envelope and the higher insulating properties to retain the temperature of the building. And by using these structural insulated panels, the operating cost will be lower and the construction time will be lesser in comparison to the traditional building or construction style. So it can save up to 40% of the cost when you are using structural insulated panels in comparison to the traditional materials.